This is the continuation of last lesson. The last lesson is about equations of tangents and equations of normals. Today we continue this, so it's a part 2 of tangents and normals. Let's do some examples. Again, we have a function, and a point is given, 5, 2, and we want to find the equation of the tangent at this point, and also the equation of normal at this point. Like what we did before, the first step is to find the slope of the tangent. Once we have the slope of the tangent, then we have a given point and the slope, so we use point slope form to write down the equation of the tangent. So let's find the slope, which means we find the derivative. For this function, we will do implicit differentiation. Implicit differentiation gives us 2x minus 4 is a constant multiple. We do nothing to the constant multiple and just do the derivative of y prime, which we use power rule. So it's 2y followed by chain rule, 2y y prime. And the derivative of constant is 0. Put in the coordinates 5 and 2. The derivative is 5 over 8. So use point slope form. The equation of tangent is y minus y1 equals m bracket x minus x1. So this is the equation of the tangent. And equation of the normal is very similar to it, point slope form, but the slope is the negative reciprocal of the slope of tangent. Therefore, the normal So the last equation is the equation of the normal. As we have mentioned in previous examples, that since point slope form is a standard form, so once you get the point slope form, you can leave it there. You do not need to change it to slope intercept form or change it to the general form. You do not need to do that. Oh, of course, this is my own opinion. I am very satisfied if you get this form and this form. All right? So next, we mentioned if you can graph the given function and also graph the tangent and normal, then this question is very, very clear to you. So let's graph this. Have you got this? So I need to erase some of these works. Divide the function, both the left-hand side and the right-hand side, by 9, so that the right-hand side is 1. Divide the function by 9, and I rewrite in this way, and change this 9 to 3 squared, and change 9 over 4 by 3 over 2 bracket squared. So why do I need to rewrite the given function in this way? Because this is a standard form for hyperbola. The standard form for hyperbola is the standard form of a hyperbola is this: x squared over a squared minus y squared over b squared equals 1. Once you have the standard form, then you can graph this. You have x-axis and y-axis. On the x-axis, you mark down plus a here, plus a and minus a. On the y-axis, you mark down plus b minus b. So I have 3 and negative 3, which is this. And I have 3 over 2 and negative 3 over 2, which is this. Once you have the 4 points there, once you have the 4 points, draw a rectangle like this. And this is an ellipse, the standard form of an ellipse. And the ellipse is inside the rectangle and touching all the sides. Oh, sorry, I just made a mistake. It's not an ellipse. If this is plus, it's an ellipse. But this is minus, it is a hyperbola. So, it is not an ellipse, I'm sorry for that. It's a hyperbola. So how do you draw the hyperbola? You draw 2 diagonals. Okay. Diagonal, diagonal. How do you draw the hyperbola? This is a hyperbola for this function, for this function, okay? Then where is 5, 2? Five, 2 looks somewhere here. Okay, my drawing is not to scale because 2, this is 3 point, this is 1.5, 2 is here roughly okay. But 5 is too close. 3 is here. 1, 2, 3, 4, 5. Oh, okay. So something like that. Now the tangent line is so the tangent line is something like that, and the the normal is perpendicular to the tangent, and which is okay. So it the graph is looks somewhat messy, but you try that. Okay. So this is the this example, both the work and also the graph. Let's have the next example. So this is a function given, and like the last example, we do implicit differentiation to find the derivative or to find the slope of the tangent. The given point is the given point is 2, 3. So let's do implicit differentiation. Power rule with constant multiple. Power rule with constant multiple. The derivative is 0. Substitute the given coordinates into x, into y. Solve for y prime. It's negative 3 over 2. Therefore, the equation of tangent point slope form y minus y1 equals m x minus x1. M is negative 3 over 2. For normal, the slope of normal is negative reciprocal of the slope of the tangent. Y minus 3, negative reciprocal of this is 2 over 3. So we have the slope of tangent and the slope of normal in the standard form of point slope form. Next, to graph it. This function is very similar to what we have before. What we have before was minus here, but now we have plus. Then I made a mistake for the last example, but I corrected it. If you have a plus, it's an ellipse. If you have a minus, it's hyperbola. So this is an ellipse. First step is to make the right-hand side 1. This is the standard form of an ellipse. So I need to write the denominator as something squared. Write this denominator as something squared. So I use calculator. 8 is 2.8 squared. 18 is 4.2 squared. Now, similar to what we did for the last example, let's mark down 4 points. This is 2.8, so I have 2.8, negative 2.8. This is 4.2 squared, so I mark down 4.2, negative 4.2. Then the ellipse is this is an ellipse. The point is 2, 3. 2.8 here, 2, 3 is somewhere here. Okay, 4.2. Okay, 2, 3. Two, 3 is somewhere here. So you draw a tangent and you draw a normal to have a good view of what's going on in this question. So through the given point 2, 3, you draw a tangent line, and through the same point, you draw a normal line. So this is what the situation is for this, this example. Let's do one more example. This is a given function. So the first step is to find the derivative, which means the slope of the tangent, and we use point slope form to write down the equation of tangent. Okay, let's do that. Implicit differentiation. U over V. U prime V minus V prime U divided by V squared. Implicit differentiation of y squared, 2y, y prime. Substitute 3, 3 into the expression. Substitution, and then work it out. I am not going to write down each step. I'm sure you can do it. So work this out. I got the answer. Y prime is it's very simple integer. It's 2. So work it out. All right. Then equation of tangent, equation of normal. As we did before, let's graph it. When x is 0, y is 0. So the graph passes through the origin. Y squared must be positive. Therefore, the right-hand side must be positive. If x is more than 6, then this right-hand side becomes negative. Therefore, x cannot be more than 6. What about x equals 6? If x equals 6, the denominator is 0, then the right-hand side is not defined. So x cannot equal to 6, x cannot be more than 6. So x can only be less than 6. Suppose this is 6, so we have no graph beyond 6. Because x cannot be 6, cannot be more than 6. So the graph is somewhere here. Can x be negative? If x is negative, the numerator is negative. If x is negative, the negative x becomes positive. Therefore, 6 minus x is positive. Therefore, if x is on the left side of the y-axis, the top is negative, the bottom is positive, so the fraction is negative. But y squared cannot be negative. Therefore, x cannot be negative. Therefore, the graph is only between the origin and 6. And remember, x cannot be 6. When x is 6, the right-hand side is undefined. So, when x is 6, it is a vertical asymptote. This is a vertical asymptote. Look at the function. Y is squared. Therefore, positive y and negative y gives the same right-hand side, which means the graph is symmetrical with respect to the x-axis, because positive y-axis part and the negative y-axis part is the same. This part and this part is a reflection. It is symmetrical. Vertical asymptote. The graph must pass through this. So what is the shape? That is the shape. Okay? Just from the discussion of the properties of symmetry, of asymptote, and so on, you can see that this is the graph. The point 3, 3 the point 3, 3 is here. So you draw a tangent and draw a normal. So this is the situation. All right? Okay. So I think it's already more than 30 minutes. I don't want each lesson to be too long, and I think I should stop here. But the example, I have more examples, so we will have part 3 next time. So I want to make some comment on this, because I saw many occasions students put too many arrows. Let me mention this. On the x-axis and y-axis, you only have one arrowhead, here and there. You never put arrowhead here, arrowhead here. You never put that. And also, when you draw a graph, sometimes I see arrow here and arrow there. Of course, I know what it means, because it means the graph will go down beyond this, go down and go up, so you use arrow. And again, I want to tell you that do not put arrowhead here and there. Do not put arrows on your graph. Never do that. Never do that. You can, if you have a textbook, you can check the graphs in your textbook. You will see that there is no arrow on the graph. But there is one thing you need to know. You cannot draw the graph just like this. Okay, this is a graph, so I draw it like that. Just draw something like that. Can you do that? I won't say that you cannot do that, but I don't advise you to do that. Because the rule of drawing a good graph is that your graph must extend to the boundary of your paper. So what is the boundary of my paper? The boundary of your paper is determined by the arrows, yeah? And determined by this end and this end. So this is the boundary of this is your paper. This is your page. Your graph must go touching the edge. Stop here. Stop here. And you don't need the arrowhead. You got it? Check the graphs in your textbook. And I advise you, your textbook must be a university textbook, because many high school textbooks have arrows here, which doesn't agree with the usual way in university textbook. So this is a university calculus. No arrow, no arrow, no arrow here, no arrow here. Oh, this is just some minor comments. Okay, see you next time. Thank you for watching.